Alright, welcome back. Now here we are, exercise 9 in module 1. Now, with this one, you may have seen this code before in another class. You probably saw it in C#. I use this same code in my COP1000 now. So this exercise is, they've given us a bunch of code as it stands. And we just need to tweak it a bit, if you will, to change what's taking place. So they say use the starter file as a reference for your solution. I don't have a starter file, I just got this. So if they're calling this my starter file, there's my starter file. So use this code as reference, write a program in which these roles are reversed. The user thinks of a number and the computer computes the output guesses. So we've got to swap things around in a way. So it says we're going to have an output message that says you're cheating. Hooray, you got it in how many tries? So let's see. We're going to leave low and high alone. Instead of my number, I'm going to change that. And we're going to come up with a different line of code. And the line of code I want to put in there is, instead of me saying, here's my number, here's what I'm guessing, I want the computer to go through and do its thing and come up with a value that is max guesses. We're going to leave count in there. We're going to do this is where our work's going to take place, is in this while loop. Excuse me. So count we'll leave alone. We want to count how many times we've gone through this. Instead of user number, let's call this my number. And say my number is low plus high divided by 2 with no remainder. And then from there, we'll take that, let's say, try and find out what your number is. So the computer's going to guess to see what your number is. Computer's going to guess it, and it's going to say, you know what, you're going to tell me, are you too high, too low, or did you get it? That's the answer from the user. So I got a number in my head, and the computer's going to guess it. And it's between these two values. And the computer's guessed it. And we've told it high or low. Say, if you got it, go ahead and get rid of this stuff because logically it's similar. If you got it, you guessed the number correct, then hooray. Computer guessed your number and we break. Do the cheating one. And we'll do some elifs to find out were we high or low. Okay, if we were too low, we drop down, else we go up. Now, it's a guessing game. And one of the things that I'm going to cover in the lecture in the course is going to be logic associated with specific algorithms, search algorithms. And that's essentially what this is. It's a search algorithm. And the best way to deal with a search algorithm, and this doesn't quite do it the way we would want to do it, is what we call the divide and conquer process. So if we're doing divide and conquer, so give me a number between 1 and 10. Well, I'm going to divide that, and my guess will be right in the middle. And that's what took place here. Divide it. Am I high or low? Or am I just right? So, the high or low, if you tell me, you're too high, well then I know it's between 1 and 5. I'll divide that one in half and conquer. Now that's a way of searching using divide and conquer. The only way that works is if the numbers are sorted, or the values in the array or list are sorted in order. It's the only way it works. If they're not sorted, that algorithm, that logic won't work. There's another way we could search, and that's item by item. Start at the beginning and work our way through it. We'll talk about that additionally in the lecture in the course. Now, each one of these different types of algorithms to perform the same task has a cost associated with them. There's two separate costs we got to worry about. One is the cost of time, the energy and time that it expends having to go through this item by item by item. If that list was sorted, man, I could get through that really fast. If it's not, I've got to go through every item. So there's a time complexity. There's also a space complexity associated with it, meaning how much space in memory is my application going to use to perform that work? If it's efficient, it won't use much space. Else, it's not efficient, it's inefficient, it uses up a bunch of space. So we'll talk about that in a lecture. Okay? So we've got this one. Let's test it and see, does it do what we want it to do? It says it's got an issue. Let me see if I've got an error. Try and run it enter the smaller number, 0, bigger number, 10. It says I've got a problem. I think it's about line 9. Let me pause and see if I can troubleshoot my error. Man, it's a silly mistake. Silly mistake. So look what I did here. I overlooked. It says math is not defined. So math is not defined. Let me go ahead and import math. And I should be fine. 0, 10. There we go. My number's 5. Let's say my number is 2. My number's 2. So, no. My number's lower. My number is 2. You got it. 2, it works. It works. The only issue that I had was I forgot to import math because I used math here. Random, I didn't need to include it because that was in the code they gave us to randomly generate a number. So in the other one, the computer generated a number and we had to guess it. In this one, we come up with a number and the computer tries to figure it out. All right. So let's run the checks again and see we all good. Yeah, we made it through that one. All right, I'll see you in the next one, which will be the final video for the Module 1 exercises.